Okay, well, let's do the next one. No, don't worry. This one's called Systems of Elimination, and it's a slightly different way of doing a system of equations. Now, you're going to use elimination when all the variables are on the same side. Hopefully you know what the word eliminate means, but if you don't, basically to eliminate something means to get rid of it. And the point of using elimination when we're solving for these things is to try to get rid of something to make it easier to solve for the other one. So there's a couple different things that I'm going to have you try to memorize a lot. Once I figured out what color I want to use. Basically, you're going to have equations that look something like this. And you see all those x's and all those y's, they're all on the same side. They're all on the left and all the numbers are on the right. And what you're going to try to do is to eliminate by adding and subtracting all the equations. So the first thing you want to do is to look for variables that are exactly the same or exactly opposite. Actually, these ones are called the coefficients, just so you know. 2b. Exactly the same. Or exactly opposite. Right? And this is the biggest thing that I want you to get through into your head. It'll help you to remember it so much. And then it's important. People are still getting mixed up while doing this. But just say this over and over and over again. Same, subtract, opposite, add. Right? Same, subtract, opposite, add, same, subtract, opposite, add, same, subtract, opposite, add, same, subtract, opposite, add, same, subtract, S and S, opposite, add. Right? Basically, you look at an equation like this, and you're looking, are those the same or are those opposite? Are those the same or are those opposite? No, that's a y and that's a 2y. But if you look at the other ones, we've got an x and we've got an x. That means it's going to work fine. X and x, are they the same or are they opposite? They are the same. And this has to do, I should be very careful with this, with the sign, positive or negative. So they're the same, so you subtract, right? Now, you're going to subtract everything, and you can do this in any order you like. I don't like having negative numbers at all. So when I subtract, I'm not going to subtract top minus bottom. I'm going to do bottom minus top. X minus x is zeta, right? Z, nothing. Just remember, anything minus itself is gone. That's the whole point. We're trying to eliminate the x's to get rid of them. So when we subtracted them, those x's are gone. 2y's minus 1y is just y. 13 minus 7 is 6. And in this equation, I made that a little bit easy for you. Just like before, don't forget to plug back in. Now plugging back in on these ones is usually a little bit more difficult. You can choose any of these to plug it back into. I usually try to plug it into the one that has the smallest looking numbers and there's no negatives because I hate working with negatives. So if we plugged it into here, you'd get x plus 6 equals 7 minus x. Oh, what the heck am I thinking right there, huh? Going a little bit crazy right out there. Minus 6 and minus 6, you get x equals to 1. We can also check it here. 1 plus 2 times 6. 2 times 6 is 12. 1 plus 12 does in fact equal to 13, which means we've done it right. If I gave you something that looks like 5x minus 2y equals 3, and then 3x plus 2y equals 5. Same steps. First of all, you look to see, are those the same or opposite? No, that's a 5, that's a 3. If you look on this one though, you got negative 2 and a positive 2. Those are exactly opposite. And since it's opposite, you know you've got to add. If we look, 5x's plus 3x's is 8x. Negative 2 plus positive 2 is gone. There's z, nothing, 0. They have been eliminated. And then 3 plus 5 equals 8. Get x equals to 1. Plug it back into this one for me because I don't like the negatives. 3 times 1 plus 2y. That y, that sounded weird when I said it. Don't know what that accent was. 3 times 1 is 3. Now you got 3 plus 2y equals 5. Minus 3 minus 3, 2y equals 2. Divide by 2, divide by 2. Y equals to 1. So your steps. Look for what's the same or exactly opposite. Determine if you're going to add or if you're going to subtract. Add or subtract to eliminate one of the variables. So that's all gone, so there's only one letter left. Solve for it, then plug it back in. That is basic elimination. Now it's going to get a little bit more difficult in a minute. So more difficult kind of problem you can get would be something like x plus 3y equals 4, and something like 2x plus 2y equals 4. Now if you were going to look at this, they're not the same, they're not the same. So there's a trick you can do. If nothing's the same, gosh, my handwriting is getting terrible. So is my speaking. You can multiply equations. To get them the same. So basically, you can kind of look at this. Can you turn a 2 into a 3 or 3 into a 2 pretty easily? Not really. But can you turn an x into a 2x? That's a little bit simpler. So you just do this. Boom. 2, 2. You just multiply everything. This turns into 2x plus 6y equals 8. Now, you look, 2x and 2x are the same, subtract. So that means you're subtracting. Once again, since this 6 is bigger than this 2, I'm going to subtract upside down so I don't get the negative numbers. 2x's minus 2x's is gone, eliminated, z, 0. 6y's minus 2y's is 4y's. And 8 minus 4, that's just 4. Get y equals 1. Now I can plug it back into any of these three. Actually, it doesn't even matter. I'm going to plug it back into this one though, because it looks like it's the easiest one. You get x plus 3 times 1 equals 4. X plus 3 equals 4. Minus 3 minus 3. X equals to 1. So if nothing's the same, you can multiply the equations to get them to be exactly the same. Then you don't have to worry about it anymore. Then you just do same, subtract, opposite, add, solve. Now, one more step.